Hello everyone, myself Shah, Maths Educator at Gajra International School. Today I am going to teach a topic based on 10th standard, which is real numbers. So before starting with the chapter, we will see the different types of number system. First will be natural numbers, second whole numbers, then integers, fourth rational and fifth irrational number. Now let us see definition for this number. Natural number starts from 1, 2, 3 and number ends till infinite. This symbol is said to be as infinite. After this, whole number starting from 0, 1, 2, 3 up to infinite. Then next integers. Integers are negative numbers as well as positive numbers. Integers -3, -2, -1, 0, 1, 2 and both side we can say they will end and start from infinite. Now the next and most important thing, that is rational numbers. Now what are rational numbers? A number which can be written in P upon Q form, where q should not equals to 0 are said to be as rational numbers. For example, if we can write 1 upon 2, 3 upon 4, 5 upon 6, these all are said to be as rational numbers. Now what will happen if this condition is not given? If q should equals to 0, what will happen to this rational number? It will goes in infinite loop. Say for example, if I'll keep p upon 0, the answer is always infinite, or we can say not defined. So here the condition should be there that q should not equals to 0. After that, irrational numbers. A number which cannot be written in the rational number, a number which cannot be written in rational form are said to be as irrational number. For example, we can say it as pi. We can say any indefinite number like this up to infinite. This is called as irrational number. Apart from this, root number, root 2, root 3, these are also said to be as irrational numbers. Now say for example, if I'll consider one example, that is root 4. Can we say this is irrational number? No, because it's a rational number. How it is a rational number? If we will take perfect square of this number, it is 2, and any whole number is consisting that is said to be as rational number. Now say for example, if we will draw a Venn diagram for this in a plane consisting of real numbers, this R is said to be as real numbers. Real number consisting of two types of number, one will be rational and other will be irrational. Irrational is denoted by q dash and rational is denoted by q. Rational number denoted by capital Q and irrational denoted by q dash. Now if we will say these are all rational, so rational will include whole number, natural number, integers. All three numbers will be there. So inside this is natural number, after that whole numbers, and after that integers. Now if we will say for this q dash, that are all irrational number, for example pi, root 2, root 5, so these are all example of irrational number. When these two get combined, they will form real number. So definition for real numbers is what? Addition of rational and irrational, or we can say combination of both the numbers are said to be as real numbers. So after learning the concept of this number system, we will see that how to find HCF. Now first of all, what is HCF? So HCF is highest common factor. In other words, we can say it as GCD also, that is greatest common divisor. Now as you have already studied in lower standard that how to find HCF, there are three different ways. Method 1, that is factor tree, method 2 prime factorization, and method number 3 long division. Let's see one example based on this method for finding HCF by any of the method. Let's start with the first method, that is factor tree. So we can write this number in this way, one will be 12, other will be 18. Now we need to make factors of this number in such a way we will get prime factors at the end. So if we will make factors of this 12, it will be 2 multiplied by 6. Again if we will split this 6, it will be 2 multiplied by 3. So you can see here three different prime factors we are getting for 12. So 12 equals to 2 into 2 into 3. If we want to write in exponential form, then it will be 2 square multiplied by 3. Same way if I will do it for 18. Here it will be 2 nines. Again we will split 9 because 9 is a composite number, so it will be 3 threes. So again we will see three different factors for 18. One will be 2, 3 and 3. Again we can write this in exponential form, so it will be 3 into 3 square. Now if you want to find HCF of this number, common numbers 12 and 18. So what are the common in both the cases? One will be 3 common and one will be 2 as common number. So here 1 time 2 and 1 time 3. So answer will be 6 of this HCF. Now apart from this, if we will see the second method of it, that is prime factorization method. This is the factor tree method, and the next one will be prime factorization. Now using prime factorization we can do numbers like this. One will be 12, other will be 8. Same way 2 6 are 12, 2 3s are 6 and 3 1s are 3. Here also 2 9s are 18, 3 3s are 9 and 3 1s are 3. So again if we will write the factors, it will be 2 square into 3, and for 18 it will be 2 into 3 square. So if we will write HCF of this two, it will be 12 comma 18, which is equals to common number from both these 2. Here also common number from this 3, multiplication of, so this will be 6. Now let's see the third method for finding HCF, and one of the important method for this chapter, that is long division method. Now how to solve any question of HCF by using long division method? First of all we need to say that two numbers, one will be A and other will be B. A will remain inside the division and B will remain outside the division. So this is the highest number and this will be the lowest number, where A should be greater than B. So here you can see the condition is matching, that 18 is greater than 12. Now let's keep this. So say for example 18 will be here and 12 will be here. So if I want to solve this question, we can write 12 ones are 12, subtraction, so it will be 6. Now as you can see that this number is smaller than this number which is outside, so what we will do is we continue the division. Now whenever we are continuing the division, that is called as long division method. So this 12 we will keep inside this. Now again we will start the division, so it will be 6 2s are 12, so subtraction, so remainder is 0. So whenever we are getting remainder as 0, at that time whatever divisor will be there, that will be your HCF of two numbers. What is the condition? Whenever my remainder will be equals to 0, at the end whatever number will be there in the divisor, that will be equals to 6, means that will be your HCF, answer of this question. Now for finding HCF, one more mathematician named Euclids has given his lemma. Now here lemma stands for the formula or condition which he has given, that is A equals to BQ plus R. This is said to be as Euclid's division lemma. For understanding this, how this A equals to BQ plus R came, we will see a normal division. Say for example if I will take 6 and 2 as number, and if I will divide it, 2 3s are 6 and here remainder 0. So in R terms what we are saying, this as quotient, this as remainder, the internal number that is said to be as dividend, and the number which is outside that is said to be as divisor. So same thing Euclides has also applied, and he said this number as quotient, this number as remainder, this internal number with dividend he has shifted to A, and this outer number is said to be as B. So here he has taken this number as in condition A equals to BQ plus R. Now by using this he has given Euclid's division algorithm. Now what do you mean by algorithm? It is a step by step solution. Whatever solution we are writing step by step, that is said to be as Euclid's division algorithm. For understanding this in a more clear way, let's take one example, 12 and 18, and we need to find HCF of this number using Euclid's division lemma and algorithm. So before starting with, first we will write what is Euclid's division lemma. What is our Euclid's division lemma? That is A equals to BQ plus R, where A should always be greater than B. So if we will write the condition like this, so it will be 18 is always greater than 12. So here A will be 18 and B will be 12. Now starting with again as long division method, if we will write this 12 here 18, 12 ones are 12, subtraction, so it will be 6. Again continue with the division, so 12 will go as dividend, 6 twos are 12 and remainder 0. So once we will get remainder as 0, say whatever number will be here, that will be our HCF. But now how to write it in the form of Euclid's division algorithm? Euclid's division algorithm. Now say for example, we can write it as step 1. Here you can see that this is its division lemma, and we need to use that same thing and apply this rule over here in this step 1. So what will be our A? Here A will be 18 equals to, what will be our B? That is 12. So here 12 multiply by quotient, that is 1, plus remainder at this stage, that is 6. So this will be our step 1. Now step 2. Again in step 2 means this much portion we will select. So in that what will be our A? That is 12. What will be our B? That is 6. Multiply by quotient is 2 and remainder is 0. So once the remainder will come as 0, so whichever number we will write over here, that will be our HCF. So HCF of these two numbers, that is 12 and 18, is equals to 6. So hope you have understood this, how to find HCF using Euclid's division lemma and algorithm. Thank you.